Alright, so I'm just gonna be like kind of like explain what I was showing you, Jack, on Friday about just how to design it. So basically what we're trying to do is we're trying to make like this motor plate, right? But like for a bigger gearbox. Specifically the one on our arm. The one on our arm is called a Gem 500 gearbox, right? So, as I was saying earlier, you have MKCAD right here, so you can look it up. Like you can look up the Neo, right? Like you'll see that the Neo it's right here, you know. But if you try and look at the Gem 500 gearbox on here, it ain't there. So what you can do though is you can find a vendor who sells it, right? And typically they'll have the CAD for it. Like, and even if they don't, they might have a drawing like this, so you can make it. So this is, a a like drawing diagram. So basically, what you can do is you can model this, right? So we want to model this gearbox so we have a reference on how to, design it. So look, we have a 3.25 inch circle. So what we can do is we can, create a new part studio and just call it, like Gem 500 gearbox. And then, first I go sketch, do front surface, and do 3.25. Um, Then you see here they have a 2.875 inner circle. And then basically there's multiple ways you can do this like orbital thing. You can use this thing called the circular pattern where you drag it to one point and you create it. And then if you have a reference, what you can do is you can go here and use a circular pattern and just kind of move this to the center right here and just set it to free right here. That'll set to 120 basically, or you can just draw the lines like how we did at the school, but as you can see it'll automatically do 120 for you. um and so yeah, now that you got that, you just look back, see that, look, they have a 1.375 inch like little step right here, so you should probably CAD that also. Remember I saw at the school that like it was kind of like you can fit everything in it inside that like space. So look, do they tell you how much the step is? I don't think they're gonna tell you. mm, let's just say it's an eighth. It doesn't even really matter that much. But yeah, now we'll just extrude it a bit, you know. Oh, not that much. um so look, it's 2.17 going back, you know. And then we can also CAD the shaft, I guess, if you want to be like all fancy and crap. And how long was it? Well, we actually cut it at the school to be a bit shorter. So it's probably like 2 inches now, honestly. Okay, so we have it like this. Um, and now what we can do now is, let me just create a new assembly. Um, you actually don't always have to make box tube from scratch, but I just like to make it from scratch because usually when you are CADing with box tube, you're like making these holes in it. And although you can get the holes like already pre-made, just from MKCAD, like here you can get like VersaFrame extrusion, right? That already has it, drilled out. But then the thing is that it's kind of hard to CAD it like that. So that's like when I'm CADing box tube, I always like to, make the box tube from scratch. Um, And yeah, so what we can do is we can create a new assembly for like our workspace, you know. Just import this here. And then since we know that like a Neo is gonna go on this guy, we can just grab a Neo over here and just slap him on. And then I'm just gonna use the fasten mate tool to connect them. Yeah. So now we got that right. Now we want to basically create our gearbox or whatever, or like our motor plate. So first what we need to do is like we need to CAD the like actual like box tube that's gonna go on it. Just based off memory, when I was at the school, I'm pretty sure I measured the length to be like 9.6 something. So I'm just gonna do that. So I measured 9.6 on the ruler, so it's not gonna be like it's gonna be in decimals, not like inches. So the way you CAD 2x1 is basically, well, it's 2 inches by 1 inch. You can use the offset tool to like move your lines inside each other. And so we have two types of box tube at the school. The one that I cut was 1/8 box tube, so that means that the inside like thickness is 1/8. But we also have 1/16, so you would just change it to 1/16 if you were using the skinny guys, you know. Um, and then yeah, now you're just gonna extrude this. Again, I measured it to be like 9.6, right? So yeah, you literally could just type 9.6 actually, 9.6 inches. Right, goes across like that. And keep in mind there's gonna be like brackets right here. But so now what you can do is essentially you can start CADing like the motor plate. So whenever you're gonna CAD a like motor plate or just like a bracket in general, like a flat piece, a gusset, you need to specify basically like where that gusset is gonna connect to it, like the box tube. So look, if we have like this section is gonna be used up with a bracket, right? It's gonna be like 1 inch. We also want to give it some clearance. So the bracket's gonna be 1 inch, and we want to give it some clearance. We'll say it's like I don't know, like 1.5, right? And then we know from here that like the thing's gonna take up like what, like 3.25 inches just going across, you know. So we can be like, okay, here, and then the distance from here to here is 3.25, right? And now we can do that little circle thing. So I'm just gonna create like a tangent line going across. It's gonna go like this, a quarter. I know that the hole, like the guide hole, is 2.875. So if I want to, get the center of that, that's just going to be half of the radius. So I'm going to be like 2.875 over 2, right? And then this would be like an example where you can use like that stuff we were talking about. I mean, I guess technically you could use the circular tool too, but you can also do it like this, where you specify that this is 120, and you got a hole right there. And then also, you'll constrain that, this to this is, 2.875 over 2 as well, And honestly, you could also just, CAD the freaking circle like that. That'll make it easier. Go here. Just be like, oh crap, what did I press? Oh, did I lose my sketch? Oh, I didn't lose it. Okay, we're still cooking. And just just like that. Then we'll get the circle. 3.25 or whoops. And then you know what? I'll actually do this. Let me hold up. Where did I specify the length here? Oh, I'm gonna make it actually a bit wider than 3.25. Or oh shoot, can I even control that right there? Here. Yeah, I'm gonna make it like 3.5. Just so the way like it has some room. So we like like little triangle forms instead. And then yeah, I'm just gonna make it tangent now. So basically, you'll make something tangent. You just click T. Then you go here, here, and then now they're tangent. You know. You can also kind of do it automatically. But yeah. If you want to make sure they're lined up, you can just form a straight line. Should be you should make that little like the horizontal symbol. Um, should also be solid right here. And basically what we're doing right now, Jack, is we're basically creating like a plate that we can laser cut out. You know what I'm saying? So I want to see if we can fit a bolt going across, because that's how I would like to do it. Because then it wouldn't really be cantilevered, because that bolt would connect it. So 1.375, and I just want this guy to have like I don't know, like quarter-inch of clearance. Because like honestly, the chain was already inside there, but I don't know. I would want to have some clearance. And look, that's plenty of clearance for that bolt. So that we're gaming, so now I'll also add the other bolts. You know what it would actually be better is whenever you're like drilling holes into box tubes, you want to kind of like standardize the distance. Like, and what I mean by distance is you always want it to be a ½ inch away. So instead of CADing relative based on here, always CAD relative to the hole you drill out and make sure it's like a ½ inch. And the reason why is because if something breaks, it allows you to like replace it with like a like comes off the shelf bracket or something. I mean, in this case, it doesn't really matter, but it's just good practice to keep in mind. And we'll just continue that going here. It doesn't always have to be exactly ½ inch. You can do like a multiple of that. And then you can really you don't even need that much. If I'm gonna be real, you probably only need like really only like maybe like 4 bolts connecting this guy up. Because look, it's gonna be supported on the bottom. Oh, you know what? Wait a minute. Am I stupid? I'm not stupid. Okay. I thought I was designing this wrong. Okay. So go across. Boom, boom, 1 inch. And then since we already have like a setup that we want to do, we'll just grab all of these, and we're just gonna move them down by just using the linear tool. You'll see like a little free. Just make that one. And then just specify this to be 1 as well. And then now we got this. So now what we can do is we can essentially just extrude this out now, right? Because this is really what we want. We just want holes for the bolts. And so we'll just do that. Just go boop, 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 boop. Go like that. Make sure it's a new material too. And then now we'll remove that material that we also created. And we'll just go like this. Bum, bum, bum. Bum, 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 bum. I mean, really, you can make it a through hole. Because, I mean, I would never use, like, riv nuts here. I would just do, like, a through hole. How I wanted to do it is, like, I want, like, the thing to go over here. So, basically, this would be, like, an axis hole for it. So, given that... Because, look. If we get this guy into this assembly, we can start to, like, kind of move it around and see how this is going to work. Because, like, we can go like this and stuff, but then you'll see like, wait a minute, like how is that supposed to work? That don't make sense, you know. And I mean, let's see. So we can go like this, you know. That's kind of how I wanted to do it. Like, see if we do it like that, right? Now what we'd have to do is we'd have to basically you know what we can do? Since it's just so close to the end, we could actually create a 3D printed crush block spacer to prevent it from like, you know, the bolts from squishing in. But like also at the same time, it's 1/8, so it should be fine if you just put bolts all the way through. You wouldn't be able to do that if it's like 1/16 though. But yeah, when it comes to like actually attaching it, many ways. Again, if it's near the end, you can 3D print like a spacer that you would slide in, and you would just like that, and you'd be fine. Or you can literally just put bolts going across, or you can use rivets. I think we're just gonna be using bolts, honestly, for this. Um, and you see here, look, this isn't gonna work right here, so we're gonna have to modify that. So let's go back and change our design a bit. Realistically speaking, like, you do need bolts up there, because then it's gonna bend. So I guess you can move it like this. I mean, like, how much material is that? That's 1/8 of material. That's probably not enough, honestly, if I'm gonna be realistic. Who cares? Let's break the rules a bit. Actually, let's not break the rules. Um, hmm. Well, I mean, we could always just make the freaking thing bigger, just so the way we have more material and it still complies with, you know, you want to be spacing out by multiples of 0.5. And look, now we got, like, what? We got point, like, basically 3/8 of material. That's good. All right, that's pretty good. So now we'll go here, and we'll be like, okay, we're gonna have to make, you know, through holes going here, and then we can put nuts on this end. So that's what we're gonna do. Um, what we could also do is we can drill these holes to be a bit bigger so it can fit the nut head in it, and then we can just have it like that. That would actually be probably better. I'm actually gonna do that. So what we can do is we can have the benefits of both worlds. Basically, first we, you know, extrude here, you know, and then we remove all that material. But then what we're going to do is we're going to make this side actually bigger so we can fit the bolt head all the way through. That way they're close and there's no, you know, exposed threads. Everyone's happy. If you wanted to do that, you can modify it to be like have a chain inside the tube. And it's just more structurally stable if you have, you know, the bolt directly connected to it, you know. And so we're going to do that. Um, or, see, here's the other thing. If I do it like this, look what's happening. It's cantilevered off, right? And you really only got like one bolt holding there. Really? I mean, realistically speaking, we should have another plate on the other side. Because, I mean, I tried to fit a bearing on this guy the other day, but like I couldn't. So, I mean, it's not a big deal because like it's not even really a big deal if it's like cantilevered off the sprocket, because like it's so close to it that it wouldn't really even really matter. But like I can't fit a thing on there. I can't fit a bearing. I already tried doing it, it didn't work. But what we can do is we can just copy and paste the plate, right? We can put two standoffs going right here, so the way it's, you know, not just being cantilevered off that one bolt. Um, but since we're doing it like this, we might as well fit a thing going in there. Like I said, you could have it if it was just one where one side's exposed and you just go in there. But honestly, since we have it like this, we might as well have a 3D printed part go here. So that's what we'll do. We'll just, you know, 3D print a part. You honestly don't really need to 3D print, you know, spacers all the time, but it's nice because it makes it so the way like there's less stress being added at these corners here because you're creating a bending force if you don't have some sort of like crush block to prevent it. And so we'll go in here. Um, Honestly, how I would CAD this is I would just go to the sketch you had right here. And what's this? The heck? Huh? If you ever see anything blue, try and get rid of it, because that means it's not defined. Oh, oh, wait. I think this is for the freaking... Okay, never mind. Sometimes it's good, sometimes it's not. This time it's good. It's just being weird. So yeah, we need a crush block going here, so I'll, create another one going from here, you know, and then I'll just, hide this. I'll be like, okay, hey guys, I'm gonna create this right here. This is gonna be a new part. Um, and then what I'll do is I'll just remove some material since, I mean, like, we know we're gonna remove that eighth section, but keep in mind when you do remove that eighth section, you honestly want to remove a bit more just because, 3D printer tolerances suck and stuff. So instead of an eighth, we'll do like an eighth plus, I don't know, like 0.025 across, I guess. And then we'll just remove all that material right there. So it's like that, And then if we go back to our assembly, we should just be able to, go insert, this guy. And basically how this work in real life is you would use your hands to basically push this guy to the surface here, and then it'd line up, and that way, it's not getting crushed. But my thing is like, why is it not lining up now? What happened? Oh, you know what? I think one of them is flipped. Or am I stupid? Uh, uh, okay. Uh, yeah, like, I mean, at the end of the day, when you're doing CAD, all you're doing is essentially you're creating like instructions for the laser cutter on what to cut, or the CNC, I guess. Instructions for the build team on what to drill. Instructions for the 3D printer on what to print out, you know. And I know it looks like a lot in the CAD, but I'm gonna be real. From my experience, like, I don't know. Maybe it's just because my 3D printer's trash, but like 0.025 around tends to work for me. Um, And if it's too big, honestly, what we can do is we can just use our, like, our belt sander to just grind it down a bit. Um, so yeah, now everything's lining up. So keep in mind in real life these holes don't exist. It's only these surface holes, you know. Um, so given that it's a surface hole, actually, mm, let me think. No, it actually probably work. Okay, never mind. I was gonna say something stupid. So now we're just gonna, put bolts here. Well, obviously, you don't really need to CAD bolts, I'm gonna be real. But you should CAD, like stuff that the build team needs to cut. So like here, when it comes to standoffs, you can use churros, you can use hex shafts. I tend to just use churros just because we have a lot of it, and it's basically the same thing as a hex shaft, at least in this application, you know? Um, and let's see, what could we do extra? I mean, really, this is what we wanted. Oh, you know what? We should also probably CAD the brackets that are gonna go here. So okay, let's do that. So we're using these. We're using this specific L bracket. I'm pretty sure it's from Rev. Or no, it's not that one. Do they have it in the CAD library? Uh, Let's see. Uh, 1 inch corner L bracket. No bracket? Maybe it's from Vex? There's like a couple robotics companies, right? You have Vex, you got Cross the Road Electronics, you got Rev, um, a couple others. I mean, dude, I'm gonna be real. For all intents and purposes, you realistically could use this one right here, because that's basically the thing we got. It has the same like whole dimensions. The only difference is that the one we have doesn't have this like little thing in real life. It's just like boing, like that. I think it's like an 80-20 bracket. But anyways, you'll notice that with all of the like come off the shelf brackets, they all have the same, profile. They're all meant for like 0.5 inch stuff. So, now we can CAD that. We can go, back in time. Be like, okay, I also want to, make some holes over here. Be like, okay, man. Nope. Be like, okay, man. I'm gonna go like, just like this. Oh, wait, why is the game constrained? Oh. Be like, I want to make it, a 1/4 inch hole. I'm gonna be real. You actually don't even really need to make it a 1/4 inch hole. I just make it a 1/4 inch because if you design around 1/4 inch, right, it allows the build team to be off by a lot and for it to still line up. You know what I'm saying? Um, but yeah, they don't need to be so precise. I mean, you still need to be somewhat precise. You can't just be having like, like holes going ooh, ooh, ooh and stuff. But then we'll have another one on this side. Uh, Wait. Remember, 1/2 inch, not 1/4 of an inch. 1/4 of an inch is only like the size of the hole. Okay. So we got that now. Now we're just gonna, remove those holes like that. Now we can go back to our assembly. Then we can just go like, beep boop. Then honestly, the way you could build this in real life is, I don't know, just from my experience, you can't really put a nut here. I mean, a button head. Like, I would honestly put a washer here just because the surface is uneven, and just put a nut on the other side, you know? And honestly, I'm gonna be real, it's fine if, like, something's coming out like this. But yeah, now we're gonna go like this. Boom, boom. You know? I mean, might as well have it on both sides, right? And yeah. Okay, so this is like another way you can mount the motor, like this. Basically, you would, use the sliding things that we use in our 80-20 to attach it right here. I'm gonna be realistic, you probably don't even need these brackets right here. Like, I don't even think they're doing anything. But yeah, so you would, put the thing right there. It's a little sprocket. Ways to tension this, I mean, like, honestly, dude, I'm gonna be real. This new redesign, now what you can do is you can literally just loosen the bolts and just connect the chain when it's closer, and then you can have someone pushing it down to tension it like that. So this new redesign also allows the chain to be tensioned easier. And yeah, that's just like a little tutorial on, like gearbox design. Well, it's not really a gearbox design, but just like motor plate design and just like, the golden rule, you want everything to be, multiples of, 1.5 away from each other, Like look, if I look if I look right here and here, I'll see that 1.375. What? Uh-oh, something's going off. Okay, we're not done yet. So yeah, always double check because you might pull a Josh and do something like that. Uh, yeah, what's up with that? Because like everything else is 1.5 away. Oh, okay. So it's not the end of the world. We'll just do this. So here, specify this to be like, I don't know, like 1. Does that work, or is that too close? Let me see. No, that works. Okay, yeah. Yeah, just, always double check before you like send stuff for like the builders to cut. Again, always make sure they're in that point 0.5 multiples. And you'll be legit. So also, let's just examine real quick. So this motor's not going to cantilever off because look, we have a bolt right here that's, pressing it to be straight like that. And then we have 2 bolts up here that are, one, not creating this plate to flex, but it also provides rigidity for this cantilevering motor. And yeah, okay, this is really it. All right, that's it.